Hello everyone, you're watching 3D Studies, this side Aadya, and I welcome everyone to this beautiful channel. And today, you know what? The doubt comes from the chapter periodic table is going to be crystal clear because in this particular video, we will be covering some beautiful topic. I would say not beautiful, it will become beautiful after watching this video of yours, but who seems like some kind of difficult topic from all of us. That could be your slater rule, or it could be your talking about the classification of metal, metalloids and your non-metals. And thirdly, what is your shielding and screening effect? In this particular video, you will be clearing each point and that particular thing. And one thing more before starting on this particular chapter, I want from you all that see. As this slater rule, we came across a lot of, writing electronic configuration, remembering of how to, calculate calculate the value of sigma for S, for P, for D, for F, and that seems so much, I could say, the problem for all of us. But you know what? Only for reading the definition or came across to the conclusion that it's difficult doesn't mean at all. What means is if you have the courage to understand it, you would be able to. So, from this particular motivation, let's begin the topic from topic number 1 of the same chapter, that is your classification of elements on the basis of your metals, non-metals and your metalloids. So first of all, talk about one by one. So what is the first topic that we are going to have is your what we understand by the classification of metals. So everyone, please put your eye on the board because it's going to be super important. I'm repeating it at all because it's important. So, what is the classification of elements? That elements in our periodic table are found. So, on the basis of metals, we often know, and I just told you, only P block is there, which includes your metals, non-metals, and your metalloids. And all the elements besides your P block are your metals. So the first point I wanted to add in this is that is your all elements of D block, F block, S block. D block, F block and F block blocks are called your metals. This is the most important point from your metals. Secondly, if I go on writing the properties for your metals, you often know from class 8 to 9 that metals have higher melting and boiling point. What I want to say, metals have usually higher melting and boiling point. This is an easy one, talking about your metallic character, right? So let's talk about your metallic characters. So metallic character of your elements in a periodic table is like, there are two cases. First case is it increases on going down the group. It increases moving down the group. We move from up to down in a periodic table. We came across that its metallic character of elements gives us the idea of increasing of their metallic character. Second is it decreases on going left to right. It decreases on going left to right. Hopefully clear to every one of you. Again, one point over here is that metals are usually solid at room temperature. Metals are solid as at your room temperature. And again, if we are talking about metals, there is a two exceptions where they're not solid. That is your exceptions are your, I would say that is your mercury and what more? Gallium and cesium. So these are the three kind of, I would say, exception in your metals which is not solid at the room temperature. So that's all for your metals. So if you are including these all points, if asked, then you would be getting all the marks for your properties of metals. But I would like to repeat it that these, I would simply say that silly questions would not come in the examination. But what's the main thing is, if you understand the gist of the properties of metal, that is your metallic character increases down the group, decreases left to right. On the basis of this understanding, your questions can come, right? So hopefully you can write it if you want to write. Then I'll erasing it for moving towards our second kind of classification of elements, that is your non-metals. What is non-metals? So again, a simple, your second is your classification on the basis of your non-metals. Right, non-metals. Now let's talk about the classification for your non-metals. So the first point which is required from all of us to remember about the non-metals is, the elements, they are usually solid, only solid, not at all, gaseous at room temperature. I like that you were writing in the comment below and you know what is the exception in the non-metal. That is your no more than boron and carbon. Clear it out? Good. Now let's talk about the second point for your non-metals. So see here, non-metals have tendency to gain any kind of electron. Clear it out? Now your third point about the non-metals are that I would say non-metals have, I would say the same thing. In metals we talk about going up to down. We came across the increase in metallic character. So what happens in the non-metal? It will decrease on going down the group. And what happened in the vice versa? It will increase in going to left to right. And down the group mean up to down, right? Hopefully clear the points regarding your non-metals. You can do right again. And now let's jump upon the third, I would say, subtopic for your classification of your elements, right? So don't worry, after this it's gonna be super important point regarding your stirring and spreading effect. We will be discussing it all, right? So what is the third point I wanted to add on is what is your metalloids properties, right? So what is your metalloid property? Property number one is your, basically metalloids are also known as your semiconductors. Not at all. Also known as your semi-metals. It's not your physics, it's your chemistry. So remember it. Also known as your semi-metal. Second point regarding your metalloids is they are found, I would say found. I just told you the table for your P block, that is your 13, 14, 15, 16, 17 and here your 18. So at the borderline, downside is your metal, upside is your non-metals, in the between it comes here the element which is your metalloids, right? So what I wanted to say, I would say they are found at the border line between your metals and your non-metals, right? Hopefully clear to you. Now the third point is going to be super interesting. What is that? Metalloids element, right? Remembering of your metalloids element, such a huge task for all of us. So see how to remember it. You can easily remember it like, see how I remember it of your list of your element that's going to come in the metalloids. That is your C, G, S, sub, T, Po, Art. It's some kind of funny trick to remember it, but you can have your own. I just remember it like CGS sub-typo, right? Hopefully clear the topic for your metalloids, right? Now we are going to jump upon the, I could say today's important topic, that is your screening and shading effect. So let's jump it. Now, we are going to discuss screening, or I would say shading effect. What is the topic here? Screening or your shielding effect. Right? Screening and your shielding effect. Now, before understanding the definition or going to jump on this particular topic, let me clear one thing to you. What is? Any such element at random, I'm going to took it, and that's going to be like any kind of elements must have your proton. Clear it out. And it have your, I would say, the orbit number 1, which contains 2 electrons. We all know 2, 8, 16 and so on, right? So what I could say is that particular electron compares your orbit number 1, which have your 2 electrons. Then again it your have your, I would say, orbit number 2, that contains your 8 electrons, and then it have your, I could see it's gonna be in circular path, right? Then it's gonna be your, right, it's gonna be your third shell, which contains moreover electrons. Now see, I'm gonna represent the electrons by red. Electron number 1, electron number 2, filled it out. Then on the second of your orbit, it contains your 8 electrons. I'm gonna fill it out 8, 1, 2, 3, 4. If you're not keeping your eye on this, you will be responsible, not me, right? So please, everyone, please focus it. 1, 2, 3, 4, then 5, 6, 7, 8. Cleared it out? Now see, what I'm gonna took it, I'm again gonna have an outermost electron, right? Because there I don't want any kind of electron, so I'm just putting it as the outermost shell. Now you all know that this particular orbit is known here as valence or outermost orbit. That is your outermost orbit. It is your valence or outermost shell or electron, right? And this is your proton, and this is your innermost shell, right, which contains 2 electrons, right? Now what's happening, or what's the story behind this? As we can clearly see that this particular positive charge, which is your proton, everyone please focus it, which is your proton. And we all know in the first chapter of your chemistry from physical that protons is equals to your atomic number, that is represented by your Z. Clear it out? Now we all know this particular positive charge with a negative charge, that is your electron, will have some kind of relation, and we often know like charges repel and unlike charges attract each other. Here's what happened. Here's the case of your unlike charges, positive and negative, they both will what do? Everyone, they both will attract each other. They both will attract each other. Okay? And secondly, what happened? These, I would say, the electrons which is nearer to each other will show some kind of Yes, you are saying right. That is your repulsion. That is your repulsion. Have you understand this particular diagram? Now, if I wanted to know on the outermost shell, the particular electron which is present, on that inner electron is showing some kind of repulsion, and the positive charge is showing in each and every electron some kind of attraction, right? It might can differ that inner electron में ज़्यादा attraction लग रहा है as compared to the outermost shell electron. Now everyone see, I'm going to erase this particular diagram. Keep this diagram in your mind and see what I wanted to say. Are you keeping it? That's good. Now let's see. If I ask you that particular outermost shell electron, जो सबसे बाहर electron था outermost shell पे, उस पे I would say some kind of repulsion भी लग रहा है, right? Some kind of repulsion is acting upon it and some kind of attraction. Now, if I say you as in random, like a question, that what if I say that on this particular electron, the attraction is 7 unit and repulsion is your 3 unit. Okay? And I wanted to know, please everyone, do let me know what is the net attraction on this particular outermost shell electron. You would directly say me that it's so easy. We will minus attraction minus repulsion, that is your 7 unit minus 3 units gonna give you 4. And that's your net attraction on the outermost shell electron. Now everyone again see. This is your electron. This is your outermost shell electron. What is the attraction? That particular proton is showing on the I would say the electrons. That is your 10. That is your 7. But what happening is, due to some kind of repulsion of the innermost shell, what is happening? That particular electron on the outermost shell is it's getting your 4 unit attraction. Means जो attraction उसे positive charge से लगना चाहिए था, उसके बजाय उसे वो attraction less quantity में मिल रहा है. Now everyone, these two topics I would say that these two pictures have been clear to you. Now see, don't forget these two pictures, and I'm gonna write the definition for your shielding and screening effect, and let us know what is your that called. See, decrease in the net force of attraction. Decrease in the net force of attraction due to innermost electron is called your screening or shielding effect. Hopefully clear everyone. What is your shielding and screening effect? That particular outermost shell electron is experiencing the decrease in the net force of attraction. जितना अट्रैक्शन पॉजिटिव चार्ज से उसे लगना चाहिए उतना ना लगने के बजाय उसे कम अट्रैक्शन लग रहा है. That means that shows the result that decrease in the net force of attraction on that particular outermost shell electron. You can add it out on the outermost electron due to the innermost shell electron. जो अंदर के इलेक्ट्रॉन है उनकी वजह से तो ऐसा हो रहा है. अगर if you can think कि अगर एक ही प्रोटॉन होता एक ही इलेक्ट्रॉन होता कोई I would say inner electron होता ही नहीं. So there could not be the case for your screening or shading effect. So what we can conclude from here, one more point, that this particular I would say screening or shading effect will only work upon multi-electron species. Right? And I hope I'm able to explain you what is your shielding or I would say shielding or screening effect known as. Now you would ask me why this particular name is given as screening or shielding effect only. Now here's the explanation for it. We all know this particular was your positive charge. This is your innermost electron and this is your outermost electron. What happening is जितना attraction लगना चाहिए उतना attraction नहीं लग रहा है. The attraction which is needed is not going to get that particular outermost cell electron. what happened? This inner electron is creating some kind of, I would say the shield, right? या फिर किसी भी प्रकार की वॉल खड़ी कर रहा है that particular inner shell electron. What happening? That particular outermost shell electron और positive charge के बीच जो attraction लगना चाहिए उसमें decrease लाने के लिए क्या हो रहा है? एक wall खड़ी कर रहा है that particular inner shell electron, and that wall can be named as shield. some kind of shield create कर रहा है या some kind of a screen create कर रहा है so that उसके force of attraction में decrease आ जाए. That is why this particular effect is known here as a screening or shielding effect. I hope that all the problem that's come on understanding this particular topic is clear to you, right? Now, before moving ahead, I would like to tell you that here we came across net attraction, and which is equals to your attraction minus repulsion. And this repulsion is denoted by sigma, remember it, and the sigma is known here as a screening or shielding constant. Screening or shielding constant. S is denoted by your screening or shielding constant, right? Hopefully clear. Now, let's jump again to the most important topic. It was also important, but after that, which is related to this topic, that is your effective nuclear charge. So everyone, please put the heading as effective nuclear charge, well known as your jet effective, right? So what is your jet effective nuclear charge, or I would say jet effective या फिर effective nuclear charge means with? So topic is your jet effective, right? So everyone again focus it. What is the definition for your jet effective? That net force of attraction experienced by outermost electron is called your jet effective or nuclear charge effective. It's your effective nuclear charge, right? So net force of attraction experienced by the outermost shell electron. So what do you wanted to say? That particular net attraction we just came out with, that is only the jet effective. Yes, you're thinking right. What we came across, the net attraction at the particular electron, the repulsion is acting and the attraction is acting on, and we'll be taking the same case over here. What was happening? That was your net attraction. Net attraction is equals to your attraction minus repulsion, and attraction is your nuclear charge. Attraction क्या था? Nuclear charge. And what is your nuclear charge? Represented by Z minus your repulsion, which is represented by your sigma. And that particular net attraction experienced by the outermost shell electron is called your jet effective. That is what your jet effective. Jet effective is equals to your Z, which is your nuclear charge. I want you to write it. Nuclear charge minus your sigma, that is your repulsion. Hopefully clear the topic for your jet effect. Clear it out? That's great. Now, we are going to have today's last topic, that is how to find the value for your repulsion. That particular electron पे कितना repulsion किस electron पे लग रहा है, how to find it. And again, after finding the repulsion, we can clearly out with what is the jet effective, because we know which element we are talking about and which element have that particular nuclear charge, and we all are aware with the nuclear charge of the elements, right? So hopefully clear this. Let's jump upon the last topic of your today, which is again similar kind of important. That is your, I would say, slater rule. So what is your slater rule is called? See, learning on the configuration of writing your slater rule, it seems very difficult from all of us. How to handle that stresses? I'm not gonna bore it by writing the same quantity of things. Let me explain it, and you would be able to, I would say, learn it, right? So, what is the slater rule? Slater rule is some kind of, I would say, the formula or slater, that particular scientist slater used to tell us how to find the value for your Selling constant or screening constant that's no more than your repulsion sigma, right? So, what is the step for finding your screening or I would say shielding effect is as follows. The first is to step it right down the electronic configuration. And wait. I'm not going to repeat it like SSP, SPS, TPS, TPS and so on. No. The electronic configuration for your slater rules is totally different from writing the electronic configuration of the element. You would say, how? Let us see how. Write electronic configuration on the basis of your slater rule. What happened is, at similar, we'll take again an example like 10. For element number 10, we write electronic configuration on basis how? SSP, SPS, right? And for 10, we can write it 1s2, 2s2, 2p6 and so on. And here's end with, right? 10. But in the slater rule, what is your requirement? First thing is, with the element given from 1 to 118, write down the electronic configuration. You know how to write. Then convert it to a form of your. See everyone. In which form? The table is your like 1s in one bracket, 2s, 2p. Let me write it, I'll explain it. Okay, it's 1, 2, 2, 1, 2, 1, 2, and 1, 1, and 2. So this is the table for your writing of the electronic configuration on the basis of your slater rule. You would say, how we will be able to learn it out? You can simply learn it out like 1, 2, 2, 1, 2, 1, 1, 2. Again, you can say, what is this? I'm not able, again, wait. Simply remember at the between it's going to be coming your, just a second everyone. Okay. So at the between it's going to come your 12, right? And here is a start with 1. So we're going to start with 1 and 2, 2, right? And here is a start with 2. So we're going to, we can say we're going to less 2 which is 1, 1, 2. जिससे start हो रहा है उसको एक बार and बाकी को दो बार. जिससे start हो रहा है उसको एक बार बाकी को दो बार. Like that you can remember it, right? So what is the configuration for this slater rule? 1. Repeat with me everyone. What is the configuration? 1, then 2, 2, 1, 2, 1, 1, 2. Again, 1, 2, 2, 1, 2, 1, 1, 2. Right? Good. Now, the second step is totally different for your S and P and D and F. What? Yes. Totally different for your the blocks, which is S block and P block. We are going to have the two conditions for slater rule for S and P differently and for D and F differently. So in this particular case, let's discuss it out of your S and P. What happened in your S and P? So what happened is, before understanding the, I would say, the rule for your S and P, let me tell you one thing. What is the particular electron on which I wanted to know to find the sigma? That particular electron or the species is known here as concerned electron. What is known as your concerned electron? And finding the concerned electron, whatever the, I would say the electrons or the species is going to come at the right side. At the right side would have no contribution. Which would have no kind of contribution on finding the sigma for that particular electron. What is this particular mean? I will be explaining it while discussing of the example. Now the second point is the same shell have your contribution of the same cell have your contribution of 0.35. What is this? Wait. Same cell have contribution of 0.35. Third is and minus 1 shell have your contribution of 0.85. Talking about your fourth n minus 2 और उसके बाद जितने भी आएंगे that have the contribution of 1.0 which is approx to 1 which is equals to 1 only, right? So what is this? How to apply these all the formulas for finding the value of sigma or repulsion? Let's move on. If you wanted to write something, you can write. I'm having a pause and let's begin, right? So let's take the example as CA, which is Z is equals to 20. Z is equals to 20, right? So let's write the configuration how I know how to write it, right? And don't worry, जितना हमने अभी लंबा लिखा था, right? That's gonna no needed of that in that particular finding of the question. What is requirement is your focus that you are not putting it all. Well, writing on the electronic configuration, we know how to write it. That is your 1s2, 2s2, 2p6. Okay, it's your 3s2, 3p6, 4s2. So this is the electronic configuration, how we know to write it SSP, SPS, right? And that's your 10 and 20. Now, writing the configuration, the first step was write the configuration on the basis of your slater rule. That was your 1, 2, 2, 1, 2, 1, 1, 2, right? So let's write it. 1s in one bracket, 2s, 2p in one bracket, 3s, 3p in one bracket. That is your 1, 2, 2 and your 4s in one bracket. Now the question can differ on the basis of, like the first question I wanted to ask you, find sigma for 4s series. Right? I could ask for your 3p also. So let's first of all discuss with 4s series. So what is going to be happening is, at the first point I just told you, 4s के बाद or at the right side, any species which is going to be coming have no contribution. On the particular sigma I wanted to find is called your concerned electron. Concerned electron, right? अब यहाँ पे तो कोई case है नहीं. If I ask you the case for the 3p, it have the 4s which is on the right side of your concerned electron, which is going to have no contribution. So we will not use this particular 4s in the question if asked for the sigma of 3p, right? Now for 3p, for 4s is what? This is your concerned electron, everyone. Now the solution goes as, right? The solution goes as what? Here is your for 4s. The first thing is we have to find for 4s sigma. Write down like this. Now how much electron is gonna come in? Here is your 2 electron. Here is your 6, 2, 6, 2 and 2. Clear it out? Now we have taken 1 electron for finding the sigma upon. So we left with only 1 electron. That is your 1. And we all know same cell के electron के लिए what is the contribution? 0.35. And that's amazing you are understanding this, right? Because it's kind of tough thing to understand it. Now everyone, this two we have done. Now n minus 1 shell में क्या हो रहा है? N is your 4, n minus 1 3. 3 वाले third वाले shell में क्या हो रहा है everyone? How many electrons are there? 6, 7, 8. I'm gonna write it 8. Multiplied with n minus 1 का contribution कितना था everyone? 0.85, which is your 0.85. Now we have further n minus 1 के बाद n minus 2 के बाद जितने भी आने वाले n minus 2 के बाद n minus 1 के बाद n minus 2 को include करके जितने भी आने वाले हैं उनका contribution होने वाला है 1.0. So here how many electron is n minus 2 has? 6, 7, 8 and included electrons is your 2. 6, 7, 8 and 9, 10. What we have is 10 multiplied with 1. Right? I'm going to solve it out with 0.35 plus 10 into, okay, it's 10 plus 6.8. 0.35 plus 10 plus 6.8. which is gonna give you 17.50 somewhat, right? You can see the calculation on your basis, right? So this is a particular thing for finding the sigma for your 4s, and that's the value came for your sigma. Now if I ask you in this only, tell me the Z effective on 4s, so you would say Z minus your sigma. What is the Z for your CA? That is your 20. And what is the sigma we found out? That is your 17.215. And your calculation is your answer. Hopefully clear, right? You can write it if you wanted to write. And if you want me to explain it again, everyone. आराम से देखो what happened है. जिस भी इलेक्ट्रॉन पे हमें जिस भी स्पीसीज पे हमें सिग्मा फाइंड करना है, उसको कहते हैं हम लोग कंसर्न्ड इलेक्ट्रॉन. आफ्टर दैट कोई भी सा स्पीसीज आए, डजंट मैटर एट ऑल, उसका कंट्रीब्यूशन 0 होता है, राइट? अब जो सेम स्पीसीज के होते हैं, जो n होता है आपका, वो उस पर्टिकुलर जिसपे सिग्मा फाइंड किया है उसको n मान लेते हैं. n is equals to 4. सेम शेल पे अगर हमने एक इलेक्ट्रॉन ले लिया, जितने भी इलेक्ट्रॉन बचे होते हैं उनका कंट्रीब्यूशन होता है 0.35 प्लस n-1 में जितने भी इलेक्ट्रॉन होते हैं उनका कंट्रीब्यूशन होता है 0.85. वी राइट इट. n-2 और सो ऑन इंक्लूडेड में जितने भी इलेक्ट्रॉन होते हैं उनका कंट्रीब्यूशन होता है 1. एंड सिंपली इसको तो सॉल्व ऑफ कर ही सकते हैं. सॉल्विंग ऑन यू विल गेट द वैल्यू फॉर योर सिग्मा, and after you get the value for your sigma, you can easily able to understand what is the Z effective on that particular element is gonna be. Hopefully clear to every one of you. Now in the same question, if I ask you for 3p, what you will do? Similar thing you will do, and you will ignore 4s2. You would say why? That's great, because it has no contributions on your 3p. And here is your, I would take one electron from it. How many electrons is here? That is a 5, 6, 7. So 7 multiplied by 0.35, 6, 7, 8 multiplied by 0.85, and 1, here is 2 electrons, 2 multiplied with 1 for your sigma of your 3p. Right? So that's the case for your S and P shells. If I ask you for the properties of your D and F, what is gonna be for them? So everyone, please everyone look on the board again. What is the case for your D and F? Now, for in this same properties, you're gonna add it all. Concerned electron and other electrons on the right side would have no kind of contribution in it. The first one which is required is same shall have the contribution of 3.5. Same shall have 0.35 of contribution. Second is n-1 and so on. n-1 and so on have 1.0 or 1 unit of your contribution. अब you will say यहाँ पे 0.85 नहीं है. Yes, that's the I would say difference between your D and F blocks for finding a slater rule, according to your slater rule, and for your S and P. Now again I wanted to repeat if I ask you the question as on the same basis for your I would say 1s2, 2s2, 2p6 as a random I'm writing it 3s2, 3p6, 4s2, and again your D with 3s10 and 3s I would say 20, 22, 2. Right? So this is when Z is equals to your 22. So this is the electronic configuration, and first thing is to write the electronic configuration on the basis of the slater rule. That is your 1s. It's gonna be your 2s, 2p, 3s, 3p, 4s. It's 1, 2, 2, 1, and then it comes your so on. So 3D in another bracket. Now if we ask you, tell me the sigma for your 3D. Sigma for your 3D species. What is the responsibility of your? First thing is to let us know how many electrons are there in the D block. That is your 2. 1 is taken. What is left? 1 multiplied with what is the contribution of the same cell? 0.35. What is the contribution from leftover elements? That leftover electrons is same 1. So that is your, I would say 2, 6, 2, 6, 2, 2. So that's your 10 and 10. That is your 10 multiplied with 1.0 and add on this. and you would get the value for some value like x. If you're gonna get it for sigma, and you can easily clarify what is the value of z effective gonna come in, that is the z minus sigma for the same species. I hope you understand all the topic in today's video. We discussed it from starting of your classification and ended with your slater rule, right? And again, I'll be back with talking you the most important topic again, which is this chapter C. This chapter is not only important for your 11th standard but also for your 12th. So if you understand each and every topic in somewhat depth, you would be able to clarify any question that comes regarding this particular chapter. So I hope you enjoyed and loved the session. So everyone, please do share and subscribe to the channel if you haven't done, and stay tuned. Thank you for watching. Bye bye.